Good morning, students. Today we'll see the numerical for the redundant trusses. Okay, so we'll take a numerical. First one, find the forces in the member of the redundant frame as shown in figure. Under the section of forces as shown in figure, so the cross-sectional area of each member is equal to 1000 mm square and E equals to 2 into 10 raised to 5 Newton per mm square. So the figure is 20 kilonewton load, 20 kilonewton load. So this is what the cantilever truss A, B, C, D, E. This is 2 meter. Again this length are 2 meter and 2 meter. Okay. So due to this diagonal, two diagonals are there. So this becomes redundant frames. So we have to calculate the forces in the redundant frames. Okay. So first we'll calculate the reactions, or we can directly start with the member forces. So we know the formula, that is to find out the member forces as equals to P force. P is nothing but the member forces due to the external forces, okay, plus X is ratio into K. K is nothing but the member forces when the unit load applied along this redundant member, and X we can find out X equals to minus summation of PKL upon AE divided by summation of K square L upon E. Correct? So now we know this is redundant member, okay, redundant frame. So we will choose one redundant member. So I will choose redundant member as a PC. Okay. Now I will redraw this figure by removing this redundant member. Now frame becomes determinant because I have removed this redundant member BC, and we have forces 20 kilonewton and here also 20 kilonewton. Okay, so we'll find out the member forces in this frame without this redundant forces. That force is called as a P forces. That forces is called as a P forces, and we'll assume compressive as a positive. We'll assume compressive as a positive. Now, simple. So when we are solving this truss by using method of joints, so first joint select where we have maximum 2 unknowns, not more than 2 unknowns. So we'll take a joint E joint E. So we have joint E is 20 kilonewton, FED and FEC, and this becomes 45 degree. We know this is 2 meter and this is also 2 meter, so this becomes 45 degree. So horizontally summation of FH equals to H equals to 0. So FEC, so FEC cos 45 plus FED equals to 0. Both are unknowns. Now summation of V equals to 0. FEC sin 45 minus 20 equals to 0. So we can calculate FEC. Okay. So FEC becomes positive because minus 20 becomes that side it goes plus 20. So FEC equals to 20 into root 2. So I will have assume direction is correct. So just I will give like this 20 into root 20 into root 2. Now here if you put the positive answer here, okay, so this becomes negative, that is FED equals to minus FEC cos 45. So FED becomes 20. So assume direction is wrong, this must be this side 20. Similarly you take the other joint. Now you take a joint C and calculate the member forces. Now I am directly writing the answers. 20 kilonewton. Solve joint C. This becomes 20 kilonewton. Again you take a joint T. Now this becomes 60. Now you solve this one. This becomes 40 root 2. 40 root 2. So we have find out all the member forces. Next. So next will be same. Now what will happen next? We have to calculate the K forces. So we have to calculate the K forces. So same sketch. Again I will redraw. Now, so what we have to do? So we have removed this redundant frame. Now we have to add the unit forces along this redundant member. This one unit force. Okay, and then we have to find out the member forces. That we supposed to is K forces. Okay. So we'll find out. Now it is very simple. So you should take this joint because there is no external forces. Now we have applied unit force along that redundant members. So this becomes, if you take the joint E, this becomes 0 because there is no external forces. Summation of H must be equals to 0, summation of A must be equals to 0. And here what will happen? So these are the 1 because the angle is 45 degree. 1 root 2. One divided by root 2. 1 divided by root 2. 1 divided by root 2. Okay, and here we have 1 kilometer along this diagonal. Okay, so these are the member forces. We have find out P and K. Now it's simple. You have a table. There we have a member, P forces, K forces, L length, area PKL upon AE. Last one is Q square L upon AE. So E is same, so I will not take E here because it automatically get cancelled out. So the member forces, we have AC. So the member forces, first one is AC member, okay, then CE, then we have ED, DB, DC, AD and BC. Now the P forces. So the P forces are these forces due to this external loading without this redundant member. So we'll assume here compressive positive, tensile negative. Okay, so I will write here compressive force positive, tensile force negative. So AC, so this is we know, so tension on the top minus 20, okay, CE minus 20 root 2 plus ED plus 20, DD plus 60, DC plus 20, and then we have ED minus 40 root 2, and BC we don't have the member, so it becomes 0. Now K forces, now these forces in AC minus 1 by root 2, okay, in CE 0, in ED 0, in BD minus 1 by root 2, in DC minus 1 by root 2, and ED plus 1, compressive force plus 1. Correct. Now the length is 2 meter, correct. So directly I will have the 2 meter. So CE is inclined 2 root 2, ED 2 root 2, 2 root. Area is same for all the members. So what is the member area is 1000, 1000, 1000, 1000, 1000, 1000, 1000. This is mm square. This is in meter. This is in kilonewton. This is in kilonewton. Now